have all heard about the Big Bang, where all life was jump-started. At least you should have. So tonight, if you look into the sky, you'll probably see stars in the universe, except probably not since it's rainy. So most people know about both of these things, but they don't know the events that transpired in between the beginning of the Big Bang to what we know as the universe today. So one of the most important contributing factors to this is black holes, which I will be talking about today. So let's talk about a scientific experiment. So a scientist / astronaut prepares to jump out of a spaceship. He's going to fall into a black hole. Do not try this at home, please, since it is very dangerous and you will die. So the astronaut says goodbye to family and friends and jumps out of the spaceship with a giant clock in their hands. So at the start, everyone would see everything perfectly fine, both the observers and the astronaut. But after the astronaut reaches a certain point, the observers will see the astronaut begin to slow down. This is caused by time warping of the space and light. So meanwhile, the astronaut would also feel fine until they reach the same part in which they would begin to see slightly blue. So at this point, they would see events in the future, technically, but it would start off slow and slowly become quicker. And since humans are not meant to see the future, eventually the seeing of the future would speed up until all the astronaut would see is a blue whirling. So then this would eventually burn out the astronaut's eyes, and then the astronaut would be blind. So back to the observers. The astronaut would appear to freeze at one point and basically stop dead in midair. So this is because the time warp has become way too strong for human eyes to see. So then the astronaut would slowly turn red and fade away. This is a process called cosmic redshifting, where the light that the human emits basically just disappears. Meanwhile, the astronaut would begin feeling some tingling in their legs, a signal that they're falling feet first towards a black hole. So they would begin to feel the tingling, and since the black hole's gravity is so strong, the small place in between your legs and your head, the difference of the gravity would be millions of times stronger. So the astronaut would begin to get stretched. So at one point, the astronaut would begin to get stretched and slowly get stretched into a noodle, and this process is called spaghettification. So the astronaut would continue to get stretched until they reach one single breaking point and snap. A very horrible way to die. But there's also another way of dying, which is a much more controversial way. Some scientists agree, some scientists disagree, and it is basically hitting a cosmic firewall, burning and dying instantly. So there are many, black holes are essentially places in space that are extremely dense, and the gravity is so strong that not even light can escape from it. So normally we see things from the light of the sun getting reflected off of an object and going to our eyes. That's how we see things. But since the black hole's gravity is so strong that the light just gets trapped in the black hole, there's no light for us humans to see, thus making them black, so they're black holes. So let's talk about some misconceptions about black holes. So the first common misconception is that black holes are cosmic vacuum cleaners moving around the cosmos, eating things up. No, they are holes, black holes, holes that things are falling into. So if you're far enough away from a black hole, you will not be affected by its gravity. For example, if the sun becomes a black hole, the Earth's orbit would be unaffected since we are far enough away from the sun. Except all life on Earth would perish because we need warmth. But that leads us to the second common misconception. The sun will become a black hole. No. So black holes, stellar black holes more commonly, stellar black holes are the most common type of black holes. They are formed from the collapse of a giant star. So if a star is 1.8 times the mass of our sun, and it reaches its end of its life by burning through all of its fuel. So what happens then? It explodes into a supernova. Then there's a remaining core. If the core is big enough, it will collapse, and there is no force able to stop the gravity. So it just collapses into a black hole, infinitely dense and infinitely small. So since a black hole requires 1.8, and our sun is not 1.8 times the mass of itself, it will not collapse into a black hole since protons and neutrons will resist each other, and since our sun is small enough that its core does not have strong enough gravity to push against the protons and neutrons, it will become a white dwarf. This is still very dense, but it's not a black hole, which has like very, very strong gravity. This has strong gravity, which is not as strong as a black hole, obviously. So let's talk about the most important role of black holes. So let's start off with the least important part of black holes. So many different physicists and astronomers have been made famous because of black holes. This includes John Mitchell, Albert Einstein, Carl Schwarzschild, and Stephen Hawking. John Mitchell came up with the theory that predicted black holes. Albert Einstein's general theory of relativity was proven really recently because of the gravitational waves emitted from black holes. Carl Schwarzschild predicted the size of black holes, like how big the event horizon is. And Hawking created the theory about how black holes eventually evaporate, which is basically over time there are like theoretical particles that form the edges of black holes, become real particles, and escape from a black hole, which slowly loses mass. So the first black holes were both creators and destroyers. So shortly after the Big Bang, there were stars and black holes. Since the stars and black holes were really big compared to the size of the universe at that time, the black holes were close enough to suck energy out of the sun. So basically, the matter would get torn off the sun and spin around the black hole. So the black hole, since they're really messy eaters, because they spin things around in them, and they slowly fall into black holes, but some of the gravity kind of flings some of the matter out into the universe. And since the universe was expanding every second, the matter got flung into the outer reaches. So these black holes were called quasars, with jets of matter that can be millions of light years long. So many scientists think that the throwing of matter into distant corners of the universe basically seeded the production of nebulas and other galaxies. So there's a big possibility that our own Milky Way was formed from the flung out matter from the first black holes. So two of the black hole's most important jobs are creating galaxies and defending galaxies. So galaxies absorb all the dangerous matter that may threaten the galaxy. So if all the matter in black holes were released, our galaxy would be overflowing with all sorts of different matter, very dangerous matter, such as antimatter and others. So without black holes, we probably wouldn't even be sitting here talking about these various topics. So just think about this, and yeah, thank you.